Question 203 says the larger circle is the inscribed circle of the square. The smaller circle touches the larger circle and two sides of the square. What is the ratio of the smaller circle to the area of the bigger circle? So the area of the smaller circle to the area of the bigger circle. So what we're looking for is this, the ratio of the area of the smaller circle. So we can put small letter r for that one, and the area of the bigger circle, capital letter R. We're basically looking for what this is, and if we substitute in, we'll find that pi r squared over pi capital R squared, the pi's and the pi's will just cancel. So in actual fact, what we're looking for is r squared over r squared, paying in mind the capitalization, of course. Then if we go back to our drawing, I managed to fill in some of the other details that I needed. So here we have our radius for the bigger circle, and there we also have the radius for the smaller circle, and I included it on both sides. So letting the radii of the larger and the smaller circle be r and r respectively, we then also have this assertion that we can make. We can say OC is equals to OA plus AB plus BC. If you see OC here, it's made up of OA, AB, and then BC. Then we can say that r root 2 is equal to r plus small letter r and r again plus r root 2. So what does this mean? We're basically saying that the length of OC, if we look at it with respect to just the other two sides, this r and this r, this is gonna be r root 2. And then we're saying this is also equal to OA, which is r, like this, and AB and BC, which is r plus r. And then lastly, okay, so there's a mistake here. This r was repeated twice, but we have the capital letter R, which is from O to A, and then we have the small letter r, which is from A to B, and then from B to C. We can see that there's an extra distance over here. If we were to redraw that triangle as well, we would see that this side is r and that other side is r, so this would be r root 2, and you can get that using Pythagoras theorem. So that's going to be r root 2. So this is what we have for the moment. What we can now do is we can collect the like terms. Putting r to the other side, we have r root 2 minus r is equal to r. You can factor out here what's left. So let me just leave it as it is, and then we'll factor on the second step. So here we're going to factor out capital letter R to be left with root 2 minus 1. This is equal to R 1 plus root 2, like that. And then we have to remember what we're looking for. We're looking for small r over big R. So we're going to divide both sides by this capital letter R, and we're also going to divide by 1 root 2 on both sides. So 1 plus root 2. This side by the same thing, R, and 1 plus root 2. Then this cancels that, and this cancels that one, and then we're left with root 2 minus 1 over root 2 plus 1, or 1 plus root 2, which is the same thing. This is equal to r over capital letter R. But then this is not exactly what we're looking for. You might be inclined to think, oh, this is the same thing as that, since it's just squared. But squaring is not linear, so we need to actually square both sides to find the result. So I'm going to start with r squared over r squared. And then on this side, I'm going to have root 2 minus 1 squared over root 2 plus 1 squared. Now let's take a look at our options for the answer. So it's not left in this format. We have to simplify it. So we can continue simplifying this until we have something solid. Taking the square of this, we'll have root 2 squared is just going to be 2. And then root 2 times minus 1 times 2 is just going to be minus 2 root 2. And then minus 1 squared, that's just going to be plus 1. All over the same thing this side, except there's a positive, so it's going to be 2 and then plus 2 root 2 and then plus 1. Then we can simplify this further. 2 plus 1 is going to be 3. 3 minus 2 root 2 over 3 plus 2 root 2. Now let's take a look at it again to see if this option is there. Okay, it's not, which means we can simplify it even further. So how would we go about simplifying this even further? Well, we normally don't have roots in the denominator, so we can multiply the denominator by 3 minus 2 root 2, or by the reciprocative of this 3 plus 2 root 2. So that's going to be 3 minus 2 root 2, and same thing for the top, we're going to multiply by 3 minus 2 root 2. Okay, then continuing off this, we multiply the bottom part, or let's start with the top part first. 3 times 3, that's going to give us 9, minus 2 root 2 minus 2 root 2, or rather 3 times minus 2 root 2, that's going to be minus 6 root 2. And then minus 2 root 2 times 3, that's also going to be minus 6 root 2. Then minus 2 root 2 times minus 2 root 2, that's going to be a positive. 2 times 2 will be 4, and then the root 2 and the root 2 are going to make a positive 2. So what we have is 2 root 2 times 2 root 2. We have 4 and root 2 times root 2, which gives us 2, which then gives us 8. So here we can say plus 8. And then at the bottom we're going to have, this is just going to be difference of two squares, because we see here 3 plus and then 3 minus the same thing. So we just square both of these. So 9 minus, what's the square of this? We just did it over here, that gives us 8. So 9 minus 8, that gives us 1, which means we're going to be left with 9 plus 8, collecting the like terms here, that gives us 17. And then minus 6 root 2 minus 6 root 2, that gives us minus 12 root 2. Then we can see that this is an option, and it's option D. So that should be our answer. And again, it's just over 1. You don't really need to write that.